What you remember about composite functions? That ring a bell? Composites, putting functions inside of other functions, composing a function in another function. And that's what we're going to do in this video. It's actually, there's two different games. We're going to play, I think, the simpler of the two. The next one's subtly tricky. Not much work involved in the next game, but tricky. This one's a little formulaic. So let's run through and see what we're talking about. So it's of a certain form. You're going to see problems that maybe look like this. Just find the exact value of the following. And the way this is working is you have a trig function, and then you have its inverse on the inside. Okay? Look at it. Actually, let's do this. Trig functions, right? No inverse on that. No inverse on that. No inverse on that. And then the interior has an inverse. And that's how it works. You can have inverses of trig functions, and you can have trig functions of their inverses. We'll keep going. Now here's the game. On this first one, we can just solve it. This is tangent of. So this is its argument, the stuff that's inside. This is its x value or its theta value. You know how we used to write like this, tangent of theta? That inverse there is theta. That's it. Remember, inverses are angles. So we go, oh shoot, what's inverse tangent of 1? Well, that's where sine equals cosine. That's at 45 degrees. Oops, nah, let's not talk 45 degrees. Let's talk radians. That's pi over 4. Well, what the heck is tangent of pi over 4? Like, are you just talking circles? Tangent of pi over 4 equals 1. Yeah. You put it through the inverse function, and then whatever answer you got, you then went and did the absolute opposite of what you just did. So maybe the inverse function was, hey, go to your buddy's house. And then the actual function was, go home. So when you combine those two functions together, where'd you end up back at? Right where you fricking started. Right where you fricking started. Because you did one process and then you did the opposite of the process. No shit, you're going to pop it right back out to where you began. As long as it's within the domain of in the range of the function, why not? This one works just fine. We don't have to worry in this game too much about domains and ranges. That's the next game. So similarly, we can go to this one and go, hey, just solve cosine inverse of 0. We know this. Figure out what it is. So cosine inverse is 0. You pull the table out. I'm going to help you out. That's pi over 2. Would you have known that? Cosine inverse of 0 is pi over 2. Cosine inverses are trippy. I jack them up constantly, so don't feel bad if that's the truth for you. But sine of pi over 2, that's 1. It's 1. You get a different answer, right? Because we didn't do the opposite process. That's cosine inverse. So it's sine of cosine inverse. Those are two different processes. Sine and cosine aren't the same thing. Unlike up here where you had the same process, just opposites of each other. These two, you know the answer can't be 0 because you're doing two different processes. It has to be. Wow, I think my voice just cracked. Am I going through puberty? I mean, I did go through puberty late, but I am in my mid-40s, so moving on. Now, if we go to this next problem, we're going to be like, well, that's cosine. Oh, you're like, all right, well, what's the freaking answer? Shit, that's an irrational number. That's an irrational number. I'm not certain what we should be able to do with that. I don't know the exact value of this. So here's how we're going to play the game. Aren't these all angles right here? Aren't these all just angles? They're all angles, so that's the same thing. It's an angle. We're just talking about angles. All right. see if we can't find this frickin' angle. Maybe we can find the angle so we can find ourselves. What the heck is this answer here, huh? Let's figure out if we can't find that angle. So I've drawn a picture. You know, it's a real pretty picture. It's not to scale. Now stop looking at the problem up top. That's not for you anymore. I'm kidding, you do whatever the hell you want to. I'm going to ask us to get theta down here. Oh, making it go away. The theta down here, I want the exact value of it. Let's do it in terms of sine. Isn't that going to be, oh yeah, that's going to be sine inverse of 5 over 13. Is that chill? That's chill. All right. Now I ask you, can you go get me cosine of theta just from this triangle? Isn't that the adjacent and that's the hypotenuse, so we're going to get, what, 12 over 13? We'll get that 12 over 13. Cool. Wait. Isn't theta equal to this? So why don't we just pop that sine inverse of 5 over 13 in for theta? Why don't we just pop that in for theta? See what we might be getting. Don't look up top. Don't look up top. Is equal to that 12 over 13. Well, instead of writing theta, we're just going to put in that sine inverse of 5 over 13. I think we just solved the problem. What's cosine inverse? Or what's cosine of sine inverse of 5 over 13? Well, we found the answer. Oh my gosh. And you know what? There it is. 12 over 13. We never have to find the angle in this game. The angle's irrelevant. What this game is doing is it's telling you, dude, I know the frickin' opposite, and I know the hypotenuse of this triangle. It told us the opposite and the hypotenuse with that sine inverse of 5 over 13. You're like, dude, right triangle, opposite 5, hypotenuse 13. Now what's cosine of that frickin' triangle? That's the game we're going to play. You have a worksheet that's right here. Composites with ratio. This is your first game. These are ratios in, ratios out. Ratios in and ratios out. The first couple problems you can solve in the first manner. Find sine of, figure out what the angle. What's cosine inverse of 1/2? You should already know that answer. You should know that's pi over 3, then you plug it into sine to go get your value. So you can write down an exact value of the expression. No rounded numbers from a calculator, I don't want that shit. And you can still play that game, like look at that. 1 and 2. This one you can play it. And then you get to here, and I don't freaking know what sine inverse of 1/4 equals. I don't know what it equals. So I can't play the game of just replacing whatever's in the argument, like the cosine inverse of 1/2 there, or the cosine inverse of negative root 3 over 2, or that tangent inverse of 1 that you should know the values of. So we look at, say, something like number 4. Well, shoot, this might require a little bit of work. Here's our game. Let's do one of these. It's 1/4. Just draw a triangle. Right an angle. And go, hey, 1 and 4. This answer up here, all it's asking for, I can already give you one of the values. Tangent is the opposite, 1 over the adjacent. Hey, just gotta go solve for a. It's the Pythagorean theorem. A squared plus 1 squared is equal to 4 squared. I was gonna zoom in this much. A squared plus 1 is equal to 16. A squared is equal to 15. Therefore, A is equal to root 15. There's a reason why I drew that triangle in a quadrant, because sometimes we're going to end up with negatives in there, and that can get tricky. There's your root 15. So we can look at this and go, get the heck up out of here. I'm going to put in that. So our answer is 1 over root 15. Make the triangle that's described in the interior, and then solve it for whatever's on the outside. Why did I draw a quadrant? If we were to have, say, something like this, sine of, and let's keep it, no, let's go, actually, let's not do sine, let's do cosine. Let's do cosine of tangent inverse of, I don't know, let's call it 1 over 5. Nope. Let's call it negative 1 over 5. Actually, shit, I can just screw everything up. Let me just zoom on in here. Cosine of tangent inverse of 1 over 5. And we want to go get ourselves an exact value of this. But we're going to keep it negative inside. We want that as a negative 1/5. We might screw up our signs if we just make a triangle. If we just make a triangle and go like 1 and 5, that's negative, you might lose sight of what's going on. So let's make a triangle. Now, tangent inverse is defined only in 2 quadrants. It's the first and the fourth. If this is negative, you must be in the 4th quadrant. So you draw a triangle in the 4th quadrant, which would say the opposite is negative 1. That makes sense. That should be negative down there. And the adjacent is 5. Dope. For us to go find cosine, we already have part of the answer. It's already there. We already know the adjacent side to this angle. It's positive 5. We just need to go find the hypotenuse. So we get 5 squared plus negative 1 squared is equal to c squared. So that's 25 plus 1 is equal to c squared. C squared is equal to 26, and c is equal to the square root of 26. So looking at this triangle, we go, it's the adjacent over the hypotenuse, 5 over root 26, and there's your solution. Dude. There's your game. Now I'm going to address number 8 before I go, and all I'm going to do is set it up for you. Just kind of setting it up. All whole numbers and variables are over 1. Sine is equal to the opposite over the hypotenuse. You need to go get that adjacent side in terms of u. Maybe a squared plus u squared equals 1 squared, then solve for a, and that will get you your next piece. So that's the tricky one. This is your quiz. This is your quiz 3A right here. Quiz 3A. Get it in. Have fun with it. It's gonna be a good time. It's not that bad of a game. You should be able to run through this pretty quick. I always use these in class as assignments. Do it. I think it'll be helpful. I'll see you in the next game.